All right, welcome back. So the kind of mathematical average of all of the currents of the ocean, surface and subsurface, gives us the Great Ocean Conveyor Belt. And again, this is kind of an important little spot here. So let's talk about the currents over here in the North Atlantic. Specifically, let's talk about the Gulf Stream. The Gulf Stream plays a large part in shaping weather patterns. The Gulf Stream is one little current on that map of those hundreds of currents, but it's a big part. It's a major component of that conveyor belt in the North Atlantic, carrying surface water from the equator up north past the U.S. East Coast, hence the ocean there is relatively warm, up north, and then sending cold, low salinity deep water back down south in the Atlantic Ocean. So it's part of that overturn in the North Atlantic, but carrying warm ocean water up, cooling down, drops below the surface, and becomes that cool subsurface ocean current. Unfortunately, the Gulf Stream as a current is weaker now than at any point in the last 1,600 years, and it's slowing down. It's still the fastest moving current at about 4.5 miles per hour, but again, it's slowing. Why is it slowing? Just like all other issues, human-caused climate change. We are doing some nasty stuff to the planet. Climate change isn't just, oh, it's getting warmer. Everything is connected. The atmosphere is connected to the ocean, which is connected to land. I hope you're starting to see that in this class, the connectedness of all of these things. So, the Gulf Stream, how it typically works, it's taking warm water from the equatorial region, kind of up again off the east coast, hence it's nice, the ocean's nice and warm if you jump in the water here, and bringing that warm water up into the northern reaches of Europe, again near that very important part near Greenland and Iceland, where it cools down and it sinks down. Well, if it slows down, you're messing with the dynamics here. Also, as the climate in general continues to warm, Greenland is covered by a large ice sheet. Ice sheets and glaciers are freshwater. You start dumping fresh water into the ocean right at this critical point where we need the ocean to drop. You reduce the salinity, thus you're making the water less dense. We want it to be more dense, a higher density for it to sink. So because it's slowing, and because of this addition of fresh water, you're really messing with this important juncture where we need this current to kind of drop down to make that important drop as it's connected to the Great Ocean Conveyor Belt. So again, the Gulf Stream is very important as it pertains to the world's climate. In about 20 to 30 years, it's likely to weaken even further, and that will inevitably influence our weather. So it's nasty. So the climate is causing changes to the current, which is causing changes to the climate, which is causing changes to the current, which is causing changes to the climate. It's a cycle. It's a cycle. And we got to stop that cycle. So because of this, we could see more storms and heat waves in Europe, but also sea level rise on the east coast of the U.S. So we'll take some time to break down both of those. But before we do, let's take so far the answers you've gotten by mathematically doing all this stuff. So take your answer that you have so far from the super secret code, and then add 3. So add 3. So additionally, plus 3. Add if you were to hit the plus sign and then 3, you're adding 3 to that answer you have already so far. Okay, again, this is all mathematically based. All right, so in Europe, what's going on? So again, the Gulf Stream helps to bring some of that warm ocean water, thus warming the atmosphere around Northern Europe. So it keeps Northern Europe warmer than it would be given its latitude alone. Northern Europe, kind of the UK, England, Ireland, Scotland, even up into Norway, you're at the same latitude, distance away from the equator as the northern parts of Canada. When you think northern Canada, you think cold, frozen. England is not really like that. Ireland and Scotland aren't necessarily really like that because of this warm current. When the current moves faster, all right, when in its faster state, more of the heat that's trapped in the atmosphere from the burning of fossil fuel, human-caused climate change, more of that is able to be kind of drugged down below the surface, 1,500 meters below the surface, from that Great Ocean Conveyor Belt and from that water sinking down. But if we mess with that water sinking down, it's not going to take as much heat, transfer as much heat to the ocean. So when the Gulf Stream is slowing down, which it is, less heat is being brought down into the deeper parts of the ocean. So therefore, if less heat is being taken away from the atmosphere, that means there's more heat in the atmosphere. That means it's going to be warmer. There you go. Yeah, so I kind of talked about that. So here is the surface temperature of the Gulf Stream. So you can see this warm oceanic water making its way up here. But if we slow that down, less heat's going to be brought out of the atmosphere. It's going to stay in the atmosphere. So it's actually going to start to cook, essentially, Europe. Then you add, again, you melting of this freshwater ice cap on Greenland. That's only adding to lower the density, where we need the density to be higher so it sinks. So climate influencing the current, influencing the climate, influencing the current, influencing the climate, on and on and on. So how is this slowing Gulf Stream affecting the East Coast? Well, there's some fancy physics going on. Let me explain what's going on. So you get this, again, that northward surface current kind of going up the East Coast leads to, so that north movement leads to a deflection of water to the right, away from the coast. So here's the U.S. over here. Here's the Gulf Stream kind of moving up past Florida, Georgia, South Carolina, North Carolina. But that flowing northward of the current actually helps to deflect water to the right, so to the east, so away from the U.S. coast. That's known as something called the Coriolis effect. It's due to Earth's rotation diverting moving objects, such as currents, to the right in the northern hemisphere. In the southern hemisphere, it's the opposite direction. There's just some physics going on. But so the Coriolis effect, as stuff is moving north on Earth, it actually helps to deflect it a little bit to the right in the northern hemisphere. The same thing with planes, or if you shot a cannonball. Anyway, so some of that water is being kind of diverted away from the U.S. coast. As it slows down, as that current slows down, well, that kind of movement of water is less to the right, away from the coast. So you're actually going to get more of that water piling up on the East Coast. Instead of moving away, it's going to pile up on the East Coast, causing sea level to rise. So again, the Gulf Stream here. So if you slow it down, you're just going to start to pile up more water in this area. So a very important part to play in the ocean's currents, in climate, and the connectivity of this to the Great Ocean Conveyor Belt. It's scary stuff. If you've ever watched the movie, I don't know if I have it sitting over here. I do not. The Day After Tomorrow. The premise of The Day After Tomorrow is kind of based on this whole process of thermohaline circulation. It's got some sciencey stuff right, but some of it not. It's a movie, but it does talk about this if you're interested. The Day After Tomorrow, starring Dennis Quaid. Or is it Randy Quaid? No, it's Dennis Quaid. Oh, and Jake Gyllenhaal's in there too. So besides the Gulf Stream, there's actually a current you probably heard of without even thinking about it. And it's the East Australian Current from Finding Nemo. Remember when Nemo was kidnapped, he and his father, Marlin. I won't try to, maybe there's some spoilers here. So Nemo gets kidnapped from the Great Barrier Reef by a dentist who brings him to Sydney and is going to give him to his niece, I think. Some crazy girl. In any case, the story is they're trying to find Nemo. So Marlin, his dad, leaves the Great Barrier Reef, finds Dory, and they need to make their way to Sydney. Well, part of that is that they hop on the East Australian Current, so for the current to flow them to Sydney to get them there faster. That's the image of that from Finding Nemo. So it seems pretty fast, but it really only moves about 4 miles an hour. Extends from the surface down to about 0.3 miles deep. It is about 60 miles wide. But anyway, there's, hey, they got some of the science right, I guess, taking the current from the Great Barrier Reef to Sydney. So, but they take a little liberty in the movie itself. But in any case, you've probably heard of this current before if you've watched Finding Nemo. Just a little pop culture reference to currents. Currents don't get much love, but here you go. I tell you what, let's go ahead and take a pause here. When we come back, we'll talk about a different type of motion, tides. I'll see, and that's the water, not the detergent. I'll see you back here in a minute.